Good morning everyone. Myself S.K. Karthikeyan, Associate Professor, Kogunadu College of Engineering and Technology. Today we are going to see design of machine elements in that Unit 5 bearings and miscellaneous elements. So we are going to start from what is bearing. Bearing is a stationary machine element which support rotating shaft or a axial and confine its motion. The classification based on the type of load acting on the shaft is radial bearing and thrust bearing. The radial bearing, here the load acts perpendicular to the direction of motion of the parts. And for thrust bearing, the pressure act along or parallel to the axis of the shaft. And the next classification is based on the nature of contact. First one is sliding contact, another one is rolling contact. And coming to the journal bearing, the journal bearings are classified as full journal bearing, partial and fitted bearing. Journal bearing is nothing but a sliding contact bearing which gives lateral support to the rotating shaft. And coming to an example of a problem from journal bearing, in this, for a journal bearing, they are given the power transmitted as 12 megawatts. So you can convert it into watts by adding it 10 power 6. Then speed n is given, that is 1000 rpm, and atmospheric temperature Ta is given 16 degrees Celsius, and operating temperature is 60 degree Celsius, and viscosity of the oil, that is given in the centipoise, that is 23. So we know 1 centipoise equal to 0.001 ns per meter square. So therefore 23 centipoise, 23 into 10 power minus 3. Then coming to the step 1, using the power formula we can find the torque. So we keep T in the one side and keep other unknown values in the other side. By substituting the given, we can get it as 114,491.56 Newton meter. And coming to the calculation for finding the diameter, we go for using some data from the page number 7.32. So here we going to consider it going to be heavy bapit liner on steel or cast iron, and having the steel the yield strength of 70 kgf per centimeter squared, that is 700 Newton per millimeter squared, and assuming the factor of safety as 1.5. So we know the permissible strength, shear strength formula as tau equal to 0.55 sigma y by factor of safety. So you do the calculation and find the value as 256.67 Newton per millimeter squared. So already we have found the torque. So by the basic formula T equal to pi by 16 tau s d cube, we can find the diameter of the shaft. Then coming to the second step, L by D ratio, you can find the length by using the data from the page number 7.31. So here we can use L by D equal to 1 to 2. There is we take it as average of 1.5 mm, 1.5, and from that you keep the L in one side and D with the 1.5. It's going to be 198 mm. And coming to finding of bearing pressure, so from the page number 7.31 table, the allowable bearing pressure for the steam turbine is 7 to 20 kgf per centimeter square. Then step 4, selection of clearance, that is C and C by D ratio. And going from the page number 7.32, for the outer diameter 132 mm, we go to column number 1, that is 140 column, and we can take some value, that is 75 to 150. So here the values are in microns, that is 150 microns means 150 into 10 power minus 3 mm. And coming to the step 5, selection of suitable oil. So our data is 60 degree and 23 poise. So for that we going to use a graph that is available in page number 7.41. So in that we going to choose SA30 oil for the given values. And step 6 is we going to calculate the bearing characteristics number Zn by P. So using the formula 7.31 for the Zn by P, we have the value 1422.3. And coming to the step 7, calculation of coefficient of friction mu. So that is available in page number 7.34. So here we can take a k value from the graph, that is also available in the same page, that is going to be 0.002 for 0.75, which is less than L by D, which is less than 2.8. So here we are taking 0.002 as small k, and substitute this in the mu formula, you can get it as 0.00616. And coming to the next calculation of artificial cooling is needed or not. So we have a formula, page number 7.34, having Hg equal to mu W V. So V is the unknown, so using the formula pi dn by 60, we can calculate it as 6.91 meter per second. And the next one is we are going to find the W. So using the pressure formula, W by LD equal to pressure. From that you can keep W in one side, so it's going to be PDN. Substitute all the unknown and you get it as 42261.9. So substitute all the WV values in the HT formula, you're going to have 1799.3 watts. And coming to the next one, heat dissipated. So this formula also available in the same page, delta T plus 18 whole squared into LD divided by K. Here we are going to find the delta T using the formula T naught minus TA by 2. So we have all the values T naught and TA as 60 and 16, and you can get the value of delta T as 22 degree Celsius. And for K, capital K, you have a constant, that is 0.484. So substitute all the unknown, you can get it as 86.4. So here the heat generated is more, but the heat dissipated is very low. So we need a artificial cooling arrangement. So for that we are going to provide a cooling fan or a circulated water. So that's all. And coming to the next topic, rolling contact bearing. So this is classified based on the rolling element, ball bearing, and roller element, roller bearing. And the second classification is based on the load to be carried, radial, angular, and thrust bearing. And this is the arrangement, rolling contact bearing. You have outer race, shoulder, ball, inner race, everything. And the rolling contact bearings are designed to take up the radial load and also axial thrust. And these are all the types of radial ball bearing. And coming to the problem, we have a given data of a type of bearing, that is 30 BC03 and speed 1600 rpm, radial load 8 kilonewton, that is 8000 newton, and thrust load 6 kilonewton, that is 6000 newton. So F4 and F0 are given. So we are going to use the 4.14 PhD data book data for 30 BC03. We are going to choose SKF 6306 bearing. So there you have the C naught value in kgf, you convert the thing into Newton, and C value in kgf, that converted into Newton. Then using the ratio F naught by C naught, you do the calculation, then you find the value as 0.411. So for this you go to page number 4.4 in the PhD data book. For the corresponding of F naught by C naught 0.411, you take the value of E, that is 0.415, by doing the interpolation. And here the value is greater than E. So you can take the X factor value, that is load factor, as X equal to 0.6 and Y equal to 1.083 from the same page. So we also need to take the service factor, that is S value. So that is also taken from the same page, that is page data book, page number 4.2, that going to be 1.3 to 1.9. So we take the average as 1.5. Then we are going to find the equivalent load, that is P equal to X FR plus Y FA into S. So you substitute all the values, we got it as 16467 Newton. So then coming to the next one, we are going to find the next data, that is L equal to C by B to the power B. So you substitute all the thing, we going to find B equal to 3 for ball bearing. So that's all. Thank you all.